All right, so section 9.2 is special right triangles. So now, when we get to like other sections in the textbook, probably in chapter 11, I believe, sometimes something like this will help you out. Again, it works for only the two special right triangles we're talking about here is the 45, 45, the 90, and the 30, 60, 90. So I think it's worth looking at. Theorem 4.5 is the 45, 45, 90 triangle theorem. In a 45 degree, 90 degree triangle, the hypotenuse, again, which is always opposite the right angle, is the square root of 2 times as long as each leg. So what it's showing us here is that the hypotenuse, again, you can always tell where the hypotenuse is. It's always opposite the right angle. And if you want to think about it, what we technically have here is half of a square. So this triangle, again, the two lengths are x and x. And so one of the things you have to remember is if they use x's on their stuff, change the variable. I always use a lot. So I can say it's a times the square root of 2, and you'll see how that benefits you here on a couple of these. All right. So on the first one here, example 1, it says find the value of x and write your answer in simplest form. So our x here is, let me see. So since they gave me an x, I'm going to use a. All right. I hope you don't mind. So this here would be a. This here would be a. And this here would be a times the square root of 2. All right. So as we can see here, a is equal to 22. So our answer for here would be x is equal to 22 times the square root of 2. Yep, it's that simple. All right, now on a couple of these, we're going to have to do a little more manipulating. But again, it should still be the same thing here. All right? So on this second one, it says x, and 10 times the square root of 2. So again, if I use my a here, I'm going to say a. I'm going to say a. And I'm going to say a times the square root of 2. So if you think about it there, we have a times the square root of 2 is equal to 10 times the square root of 2. So if we look at it, to make those even, because that's what equal means, well, our a here would have to equal 10. All right? So if that's the case, well, what is our a? It's x. So we're going to just say that x is equal to 10. And now our last one here for the 45, 45, and then we'll talk about the 30, 60, 90 one, okay, is on this one here. Again, we're going to do the same thing. So again, here is my right angle. So we know that's my hypotenuse. So we know that this one here, since that's a 45, we know that that one here there is also 45. So again, we have a 45, 45 triangle. All right. So again, think we're going to have a, and a times the square root of 2. Okay. So on this one here, we can say, and I always tell people, look at the one where you only have one variable, and you're going to solve for that one variable. So on here, I have an x and I have an a. Well, I can't solve for that. Same here, x and an a. I can't solve for that. But on this one here, I have just one variable, my a. So on this one here, I can say that a times the square root of 2, sorry, I put a 12 there, I didn't mean to. So a times the square root of 2 is equal to 12. So now remember, to get a by itself, I'm going to divide by the square root of 2. But now remember, the other day when we had that extra practice on radicals, remember, you have to multiply this by 1 because you can't have a radical in the denominator. So I'm going to multiply the top and the bottom by the square root of 2. So just think, the square root of 2 divided by the square root of 2, that does equal 1. It's just the same as if I had 2 divided by 2. Something that's on the top is the same as something on the bottom. So we technically have not changed the problem. All we did is we made it so that we can take the bottom here. So now remember, what did I tell you yesterday? When I have two that are the same number and I'm multiplying, it's just the number underneath the radical. So again, think about it. It's square root of 2 times the square root of 2. I can take the 2 times 2, which is 4. So the square root of 4 is equal to 2. So if we think about that, we should get 12 times the square root of 2 divided by 2. Now, on this here, remember, you can still reduce the fraction if possible. Now remember, the only part I can do is I can do the real numbers with the real numbers. So I can take this part right here, and what is 12 divided by 2? Well, that is just 6. So my answer will be that x is equal to 6 times the square root of 2. And that is what you would have to put in your answer. Because remember, it's saying in the simplest form. If it's in the simplest form, that means it's in radical form. Okay, if they tell you to approximate, then you can go ahead and use your decimal. Okay, all right. And we'll see that because we'll do a couple of word problems here in a second. So theorem 9.5 is your 30, 60, 90 triangle theorem. So in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shortest leg, and the longer leg is 3 times as long as the shorter leg. So kind of look what they have here. Across from the 30 is your x. Again, I would call it A. Across from your hypotenuse is 2x. And then across from your 60 degree is x times the square root of 3. If you get into the habit of just thinking 30 degrees, x, that's your x value. And then you're going to have to make adjustments as you go on. Opposite the hypotenuse, these two things are kind of worth memorizing, both of these, especially if you go into trig after you take algebra 2. So example 2, find the values of x and y and write your answer in simplest form. So just like I did on the 45-45, I always like to write this as a, 2a, and a times the square root of 3. So again, the way I see it is I'm going to take the one that only has one variable because that's the only one I can solve for. So if I look at this, they're telling me this one here is 60 degrees. So I know that this one here has to be 30 degrees. So if that's the case, again, just think it's a, it's 2a, and it's a times the square root of 3. Looking at that, which is the only one that has one variable? And you would tell me it's that one right there. And I can still set those equal. All right. So we can say that 2a is equal to 30, or A is equal to 15. Okay, so if A is equal to 15, well, Y is equal to A. So Y is equal to 15. And X is equal to A times the square root of 3. We just said A was 15. So it's 15 times the square root of 3. Okay? All right. Now, sometimes we're going to have to do a little thinking here and fixing stuff up. So example 3 here is a word problem. Again, I gave you a couple of real-life examples. A warning sticker is shaped like an equilateral triangle with sides 4 lengths, with side lengths 4 inches. Estimate the area of the sticker to the nearest tenth of an inch. So remember, what do we remember about our triangles? Well, the area is equal to 1/2 the base times the height, but I've found that a lot of you like to say base times height divided by 2. All right. Well, if we take this, we have, they said that it's an equilateral triangle. So we know that this here is 60, and we know this is 60, and we know this is 60. All right. We know if we take this triangle, and why don't I change it to red here, and I cut it in half here, I still have a triangle. All right. But now they told us that the length of this was 4 and the length of this was 4. But now remember, if I drew that straight down, I'm going to have a right angle there, and it's going to bisect each side. So we're going to have 2 and 2. All right. So the area of our triangle is going to be 1/2 the base times the height. All right. So there's one of my 1/2s. Okay. And here is 4. And remember, since I just cut that 60 degrees, I have 30 here, and I have 60 here. Sorry, I should have drawn it a little bigger. My apologies. And again, this here is a right angle. Okay? And so think about it. This here is our height, this distance from here to here. So this is going to be our height. Okay? And why don't I just put H there for us? Okay, now I want you to think again, and I'll switch back to blue so we can see it. Opposite the 30 is A. The hypotenuse is 2A, and then H is A times the square root of 3. So in this case, our A is equal to 2. We already know that, all right? So on this one here, again, that makes sense. 2 times 2 is 4. And on this one here, since our A is 2, we can say that H is equal to 2 times the square root of 3. Okay? So now remember, we're going to say our area of our triangle is equal to the base. Well, the base is the whole thing here. Now remember, I'm taking the whole area of the whole thing. I just had to break it up so that I can find out what the height was. So our area of our triangle is base, which is 4, times the height, which is 2 times the square root of 3, and that is going to be divided by 2. All right? So if you think about it, you can just plug all of that into your calculator like that. They told us to round it to the nearest tenth of an inch. If you plug it into your calculator, you should get 6.9, and that will be inches squared. Okay? And finally, our last problem. A tipping platform is a ramp used to unload trucks. How high is the end of the 54-foot ramp when the tipping angle is 30 degrees? Okay, so they're telling us here this tipping angle, and again, why don't I go back to red since that's written in blue, unless you're making a copy of it and you don't have color copy, that would be 30 degrees. So we know that this one right here has to be 60. Okay, and we know that our height of our ramp, so now this here, now just a mind to think about it. This is our ramp. When it's tipping, this is still our ramp. Okay, that is still 54 feet. Okay, the ramp doesn't expand, it stays the same length. Okay, so they want us to find out how high is the end of a 54 ramp. So they want to know what this is here. So this is our A, right? This here is our 2A, and this here is our A times the square root of 3. Okay, so which one do we need? Which is the only one? Because again, this would be our height, right? So that would be A is equal to H. We don't know what this length here is. Now it's no longer 54. Remember, the 54 was that ramp that stays rigid. And so on this here, we don't know what that is. It would be another variable, say x. We might need it, we might not. By the way, we don't, because it asks what is the height. So if we look at it, the only one where I have a variable is this one right here. So I can say that 2a is equal to 54. If I divide by 2, I'll get that a is equal to 27. And again, our a is equal to our h. So that would be 27 feet. Hopefully you can see that this is an easy one and it is worth remembering. All right, especially if you go on to trig, ladies and gentlemen. Thank you.